begins, can you all please go on mute? People who are not speaking, there is a lot of background noise.
So it's video recording, sir?
So can I start it?
Yeah, I initiated the meeting recording. You can start.
Thank you, sir.
कल है ना ये मुकेश को मैंने कॉल पे लिया था वो उसके लिए
Yeah.
Okay, let me share my screen. Just let me know if everybody is able to see this.
Yes, Mahendra, your screen is visible.
Yes. Okay. Thanks everyone, and thanks for joining today's session. I hope in the past couple of years we have been working on a lot of digital application modernization and also the modularization as well, in terms of like the context is like, suppose if you start with suppose if you want to watch any Netflix streaming video or any kind of an payment transaction which we are doing it, or maybe recent avatar, whatever the kind of buzz which it has created. So all these use cases which gives me a great thought in terms of understanding how what was the architecture behind to make this application so scalable and agility, and in terms of maintainability, and also it is reliability. All these terms are the basic fundamentals of the software architecture actually. Okay, so whether it is an avatar, which recently we saw the visuals of this one, where the cloud made one of the cloud service called AWS FSx, which gives a larger initiative, like what I heard from that in one of the info magazine is that James Cameron from the Amazon complete data center of Australia and New Zealand has taken over, because of they want to create the visual wonder to see that to see in a very high resolution mode, so that they should create an entertainment to the customers and the clients and all over the world. And also, when I saw that Netflix recent Skype game, which was touched almost 111 billions records, and without any network glitch or something. But and also during the pandemic time, many of us are habituated to the phone pay transactions or any kind of a phone pay or Paytm or UPI transactions. It becomes since we are habituated to this digital payment contactless payments, everything is, there is some behind that, there is an architecture behind it actually. Okay, how each and element which we talk about, each of the use case which I talked about, how that modernization of applications was built actually. Okay, microservices, like I put forth, the microservices is one of the important architecture style along with the monolithic, and there is other architecture software styles which was there, like event driven and domain driven, and also there are many other things which was going on in the current trend actually. Okay, but microservices become a very imperative trends to imbibe the lot of the application modernization and modularization actually. Okay, but to make successful of microservices, there are a couple of elements and components which help them to grow successfully. And there are a couple of things like containerization, adaptation of the cloud, and also to the artificial intelligence, which is becoming a more buzzword nowadays, and also a service mesh. Today, I am going to just talk about only these trends actually. There are other trends which are there in the market, but these are my this is my thought process which I want to introduced you all about what are the different and how it is impacting the microservices architecture style actually. Okay, as a software engineering leader, we always often think about why we have to introduce some architecture style to the existing monolithic architecture style or something. It has to always think about why, what, and when. These three W's, which will makes you think about what makes an architecture to move forward from one style to another style actually. Okay, there may be. So coming to that, okay, why microservices? Microservices, which will predominantly we are using in a couple of years from the all enterprise organizations, because we do have some kind of an setbacks for the monolithic architecture, because it was a tightly coupled architecture where we can't introduce any kind of a new technology. Suppose if you want to add any feature, we need to deploy everything to the we need to deploy everything entire application, and then we need to rely on operations team to move that one. So the customer is not able to because like I said in the introduction, everything whatever the customer is which is expecting in a real time and a fast based actually, because he wants an instant. Because if you see an app like Blinkit or PhonePe or e-commerce application, anything, because whatever the orders which they want to make it, they want it in a real time. So in order to make in a real time, how the architecture should be scalable enough to handle that many requests from the customers so that they can able to deliver it. So that is what the behind it. So with the monolithic architecture, I'm not saying that we can't achieve that one, but there are certain setbacks like flexibility for the introduction of a new technologies and polyglot architecture which you want to build it. It's not possible to do with the monolithic architecture actually. But with the introduction of microservice architecture, we can create a backend applications separately based on the bounded context. Like let's say, suppose if you are working on a Amazon e-commerce application or Netflix, it was everything whatever they built in architecture is like a bounded context actually. Suppose if you take an e-commerce, if it's a payment service, it's related to only the domain which is consigned towards the part of the payment transaction which you are going to make it. At the same time, whatever the review services like post what you make for the product, the review service is a microservice. Stars, whatever the star which you are giving, it's everything is a small microservices, so that everything is communicating each other, okay, in a isolated environment section. Okay, and also with the recent introduction, there is a micro front ends frameworks which was predominantly taking the like how microservices has become a trend. Micro front ends also becoming a trend, so that UI components can be decoupled it in based on the services actually. Okay, so with that service, I mean I just explained this how that why we need the difference between the monolithic and the microservice architecture actually. Okay, and if something goes in any of the microservices in the monolithic application, we have to scale down we need to shut down the complete application. It might shut down the complete application, but in monolithic application, it doesn't give any kind of an impact to the whole application, so that it will be available actually to the customer on a need basis. And also because of the nature of the resiliency and fault tolerance, microservice architecture, whatever the applications which you are building, it will be available to the customer on 24/7. Okay. Yeah. But what are the microservices actually? We talked about the flexibility which is providing the microservices, all those things actually. First in 1997, in 1999, these people, HP Labs, the first research towards microservices has brought into picture actually. Okay, then how we need to create it in 2015, in 2005, micro web services was termed by the Peter Rogers in Google, where he introduced to create a small component of a service. We can create a small manageable pieces of independent application so that we can deploy it easily and then maintain it. So that's where it started. Yeah. With respect to the architecture, yeah, well, what we can think about is we can decouple all your service layers, and we can create a domain specific and the bounded context layer information, so that right, uh, eh, because of the agile culture which we are working on, every team is responsible for that particular bounded context, whatever we have feature which we are working. Suppose if the payment team is working on some enhancement, like during the pandemic time, before that we don't have a UPI culture actually. Okay, everything is NDFS, RCS, all these payments which we are doing it in a different transactions mode. But UPI becomes brought a cultural shift in terms of application modernization and also modularization because of the microservice architecture, where we can introduce a new feature within a short period of time. Because that time, during the COVID time, no one was able to give their currency to another person because of the contactless, to avoid the COVID virus actually. Okay, so suppose during that kind of a time, suppose if you want to introduce any kind of features, we can able to easily adapt it, integrate it, and we can deploy it easily. So through the microservice architecture culture actually. So that is there. Okay, so what is the advantage of microservices? Microservices gives a lot of features in terms of like decoupling, because like I said, right, we'll be decoupling the entire application based on the bounded context, and they easily build and modify it actually. Okay, and also componentization actually. So what we can do is, suppose like I said right in the before, suppose if you want to introduce any feature or something, we can easily build that feature and we can deploy it and roll it actually. There are some business capabilities like this is one of the design patterns which we'll be talking about for the over period of time. This is a basic principle, like a single responsibility principle. So what that microservice which it will help you is that microservice which is only responsible for doing only that context actually. Suppose if you are doing an order service, it will be doing only that service, not on, there is no conjunction between the order service and the payment service. Okay, autonomy. Like I said, agile is one of the way of working style, like before that waterfall model, because where the productivity we can see in the at the end. But with the introduction of agile culture, agile scrum methodology or XP or some different whatever the methodologies which we are using for the product development, the product which we customer is able to see it on upfront in a short period of time. That we call it as a minimum. I will go back to the advantages which we are discussing right now. So autonomy, because since like I said, right, we are working on an agile culture where people are independently can work on the different teams actually, because microservices is all about developing that application based on the domain or the feature which they want to create it. For example, if order team of e-commerce application can work on only particular that one, they can have that complete control on that feature itself. Okay, and they can work on whatever the feature and improve the speed in terms of the whatever the build which they want to do it actually. Okay, continuous delivery, which is one of the adapted feature which is there in the microservice architecture, which helps to deliver your application in a fast-paced manner. Like I said, right, during the pandemic, we are not habituated to the UPI culture at all. Okay, because everything we are driving through the cards, currency, all these things actually. But UPI is a very fast-paced digital transactions which we can make it. So how we can achieve that? Because if you are building the feature and we need to deliver it right to the customer so that customer is able to use that feature and within a short period of time. So continuous delivery certainly helps in a DevOps culture to move your application into the production environment for the customer needs. Responsibility when it comes to that, as I said, right, it is not of the focus on the application projects. It is about the product, because it's not about microservices is all about it focusing on the what feature we are giving it to the customer and how best it is helpful for the customer actually. So that is very important actually. With respect to the governance, I have a very detailed, not I don't have enough knowledge on with respect to the centralized governance, all these things. But with respect to the focus is we have where when it comes to the enterprise architecture, right? Some people might use the different platforms. Okay, some go with the Java language, some go with the different tools, some go with the and that is depends on the how the business use case is. Like I said, right, it is not the application of the project. It is about the customer, how best we can give it. That is one thing. Agility, yes, it is extremely important in terms of delivering the product actually, because working on a application modernization and modularity is one such case, because we have to understand the process of and how the agile culture is going to work, because Scrum certainly help to give your product in a very minimum, I mean, we call it as a minimum viable product. So whatever the feature which we are building, it will we can give it to the customer in a very short period of time. So with that, I think Scrum and extreme programming, I think like how we have the waterfall model, which has some kind of limitations, but the Scrum and agile culture really makes a difference actually. Okay, so how we can migrate your monolithic applications, actually monolithic software style architecture to the containers or whatever the new I mean microservice architecture actually. Okay, so if you have a big monolithic application, I'm not completely say that we have to we can migrate all monolithic application to the microservices. There are some places where the continuous improvements are happening in the certain resources, like let's take an example of the payment service. Today, there are many features which we have, many applications which we are building through the payment service. Payment features is very much needed in a day-to-day activities. Actually. So how can you in an e-commerce, big e-commerce application can migrate their monolithic application to the microservice architecture? They need to identify the resources actually. So they need to identify the resources and set the bounded context, and then they need to migrate that service and deploy that actually. So define it, use that as a bounded context, and see what is that. Is there any shared component in terms of when you are migrating it actually? Okay, so re-architecting is really a cumbersome job in terms of migrating from monolithic to the microservices actually. Okay, there will we have, because since most of the whatever the applications which we have is like an API driven, so like a client server architecture which we have actually. Okay, so we need to understand what is the best we have to use it actually, whether we have to go with the REST client server architecture or an event driven or a domain driven. So event driven is like basically how the e-commerce applications is working on actually. Okay, service to service communication, or when the order is created, how the order event is transferred to that other service actually. So that is the RESTful web services. It's like a simple suppose if you're building in an application to the view the product or see the product and some kind of an crude operations which you want to do it there, we can use the API driven approach actually. Okay, so with that I would like to talk about the containerization. Actually in the traditionally the more old in in older way, the deployments are happening in a very, I mean, not in a very frequent time. So suppose if you build some application, it will take some time. It will go with the waterfall model and all those things actually. So creating that and giving it to the ops team, operations team, and then they have to think about what is the, they have to create databases, networking, firewalls, all those things to up and running the application actually. So containerization, which certainly help your application to ship and build, ship, and move it to the one kind of Docker hub, so that any platform can use that image and use that actually. Okay, so the containerization, what is containerization basically? So containerization basically, it's a lightweight virtualization technology that allows you to package an application and its dependencies into self-container called a container. A container is nothing but a software, a small unit of work where the application is going to execute it actually. Suppose if you run any payment service, it will run in a container actually. So, and then whatever the resources which was utilizing it, it is running on top of that virtualization actually. Okay, so what is the benefit of the containerization? It gives the portability, as the same container can run in a different machines. Efficiency, yes, in fact it has that efficiency, because if you're, suppose in a big Amazon Black Friday or sales or something, right, you have to scale your application in such a way that the container resources should not be overhead actually. The contain, suppose whatever the services which you are building it, which you are deploying it, which is running in the resources, it should be a scalability during that what is the budge time actually. Okay, scalability certainly helps actually. Isolation, because every container, every payment, whatever the microservice which image which we are creating it, it has this isolation which is running on a own container actually. Versions and rollbacks, in fact, yes, because when you run your application, we'll be maintaining the different versions of the application actually. Rollbacks is certainly needed, and washing is certainly helps, because suppose when you are deploying some application, certain markets might not use that version, and there certainly that versioning certainly helps. And if the market is not kicking up, we can roll back to the previous version, what is working previously, and then use that one. So that way it has a lot of flexibility in terms of containerization actually. Okay, yeah. How can you achieve this containerization? We do have a de facto standard tools or applications which we have. One is Docker, another is Kubernetes, which helps in the container orchestration. Okay, and recently I'm hearing the Podman, which is taking the buzzword in terms of how that we can build a containers or Docker images or images which we want to do. Okay, so Docker certainly is the most widely used container engine, which we can be able to create your microservices, and then create an microservices and create an image and deploy to the Docker hub. From there, anyone can use that image and deploy, use that application and this one. Most of the cloud-based, cloud-native development, which is happening through the Docker only. Okay. We do have a Docker Swarm, but Docker Swarm and the Kubernetes will go in head-to-head, because Docker Swarm helps in a small and large, small and medium applications which you want to build it through the orchestration actually. Okay, but Kubernetes has is a lot of flexibility in terms of creating it, because it gives a lot of orchestration where the controlling mechanism has been a lot of features actually. Okay, where we can do the automatic deployments, we can do the scaling, we can do the management of this one. Everything is completely done by the Kubernetes. They have their own flavors, like every cloud has different different containerization Kubernetes engines. Azure, AWS is having AKS, Azure has everything. GKS is also is having their every cloud provider having their own Kubernetes engine, but the specifications which was whatever the built by the Google actually. Okay, yeah, it will give you the load balancing also. So that is our scaling and whatever the monitoring which you want to do it, and also the service which I could about. Okay, like I said, right, there is only the difference between the Docker and the Podman is Docker works on a real RESTful architecture platform because it has its own domain. Suppose when you install Docker desktop in your system, when you run your application, it runs in a domain mode. Okay, so whatever the commands which you execute in the CLI or from the Jenkins pipeline or what something, it will works on the client server architecture. It will go to the command. Suppose if you're giving Docker run something, Docker and then run, it is a REST API which is invoking that one and this one. But the problem is if the daemon process, if the daemon is crashed, we are not able to see the containers, we are not able to build it. That is the problem with the Docker. But Podman has overcome that one, but still it's a long way to go, and also with the containerd actually. But it's containerd is same as Docker, but it's a little lightweight and secure architecture which was built actually. Okay. Yeah, like I said, right, where we can use the Docker containers actually. Suppose if you want to do any kind of a lift and shift from the on-premise applications onto the cloud, and then how when you are refactoring your existing applications and then which you want to build it to the containers, we can do that. Like not going to, if you create a microservices in a small component, and if you're not using the container, that doesn't make sense because we have to use that as a containerization so that it will help actually. Yeah, in fact, containers certainly help in the microservice architecture so that we can use this. You can deploy this same Docker image, whatever we have created, into the irrespective of whether it is a Redshift platform or Kubernetes or any other platform section. Okay. Yeah. Provide the DevOps support for the continuous integration development. Yes, in fact, CI/CD continuous integration and the continuous development and delivery, deployment and delivery, which is very much imperative in terms of microservice architecture, especially when it comes to the containerization. Okay, so whatever we were going to build it, we can build easily and ship it. So that's the DevOps support. Like I said, we can able to using the Jenkins pipeline with the multiple stages where we can do that. We can run your background process, everything into the containers. So that one. This is the first image is it is how that REST architecture, which is like I said, right? It's a client server architecture where if you give the Docker build, Docker pull, Docker, it will connect to the Docker host where the Docker daemon is there and where images are residing in the Docker Hub registry, and it will pull that images actually. Okay, and then so one of the thing what I understood in recent years is like earlier during my initial days of development, when I joined a new project, we need to install a lot of projects, lot of softwares actually. Okay, but with the introduction of AWS workspaces or the Redshift dev workspaces, the need of the need of installing all the software to run your local machine, it becomes an deprecated actually, and so many people are going for AWS workspaces and this one. So if you have a little bit one computer where you have the flexibility to connect to the internet and the connect bandwidth and this one, all you can do it everything in the this one. So how that is happening, because one of the feature, the containerization. So suppose if you want to install the JDK, you don't need to install it in your system. You just build, if you have a Docker desktop, you just download that engine image and you can install it and run it, and then you can shut down it. So that, right, resource efficiency of the system will be better in terms of usage actually. Okay. So how you are going to start with the containerization journey? Like I said, right, we need to identify certain resources where we have the frequent changes of the application, so that instead of deploying a complete application, we need to take over that application and build a containerization and move it actually. So create a Docker file, and the Docker Compose, where there is a Docker file which will just create a sample, a kind of a commands where we will be giving the commands, and then it will provide you to create the Docker file, Docker image. But Docker Compose is ahead of that one, but it will give the what you call, if you want to build a multiple services for application, like I have 2 microservices, 1 database, and also maybe 2 databases or 3 databases. So how we can do that? Because we are creating a service architecture, services in the Docker Compose file, we can create that, and then we can, if you use just Docker Compose up, then automatically your services are up and running, and whatever this JDK or everything we can give it in the Docker Compose. Orchestration, as I said, right, like Kubernetes and the Docker Swarm are two contenders, which is really helping our container orchestration for the microservice architecture. Docker Swarm, some extent, it will be helpful for the small and medium-sized application, but Kubernetes for the large and complex applications where it needs kind of a load balancing and then monitoring and whatever the features which we have it actually. Okay. And also, right, we are building this images, and it should have a kind of an authenticity actually, because security is always security is always plays an pivotal role in terms of whatever the containers which we will be building. Okay, suppose if you create an image and if it is available in the Docker Hub, but doesn't make sense because anyone can access that image and run it. But we should have that the kind of a security mechanism in place where only the authorized and privileged people should be able to access that application. Okay, so that is one thing which you need to take care while building the containerization. Yeah, the second trend which I'm going to talk about is about the cloud and the native development. Okay, I think past few years we are hearing a lot of buzzword in terms of cloud and native development, where people are always talking of the cloud, but on-premise is indeed many monolithic application. Many organizations are not shifted to the only certain percentage of people who adapted the cloud culture. There are some benefits. There are certain limitations which we have in terms of adaptation of the cloud. Okay, the cloud, especially with respect to AWS, Azure, and Google Cloud, 3 front runners, which is making us our life easier, because any organization which they want to build any greenfield projects or the existing blue projects actually, or brown projects which we have. Okay, they are thinking to adopt the cloud architecture because they don't want to focus on what is the infrastructure it takes actually, and how much it costs, and what is this actually. In general, in monolithic application, we are not sure how much scalability we need for our application. We don't know what is the database size we have to think about it. What is the storage for our application? What is the logs which you have to think about? But a cloud certainly helps in large extent, give you a lot of flexibility in terms of building your application. This one actually. Okay, so cloud adaptation, like I said, right? If you have an application, you can do in cloud. You can do anything right from the right from the building application, and if you do any kind of a cloud commit, cloud, there are various plethora of services provided by each of the AWS or Azure or Google Cloud. But everything, the fundamental architecture is a cloud computing, okay, where it works on the application hosting models. Okay, on-premise, everything, whatever I am describing it here, everything in on-premise like application, runtime, whatever the middleware or OSS virtualization, everything should be taken care by the respective individual organization team members. But when it is shifting to the infrastructure service, yes, there are certain things which will be managed by vendor and certain things which will be managed by our development team or operations team. Okay, but when it comes to the platform as a service, yes, in fact, only the limitations what our organization is going to manage become less, like only applications and the data which you are going to manage it, and the rest of the things which will be taken care by the whatever the cloud providers actually. Okay, with that, we are again shifted to, like I said, right, as a software engineering leader, we always think about why we need to move forward. Again, we move forward to the a software as a service. I never saw nowadays we are when I was working in my earlier days of programming, the IT people come and install Microsoft service, Microsoft Office in each and every individual systems. Okay, but that need has been reduced over the period of time because we will have the office365.com where we can use that Office 365 as a software service, and also Google Gmail, which we can use it anywhere actually. So that the shift of application hosting models has been changed actually. Okay, so in fact, all these features which is going to provide by the clouds. Okay, in fact, you can run your on-premise applications in the cloud itself, infrastructure as a service. Like suppose if you're deploying any application where you can choose your application which you want to run it in, whether it is in a Linux, whether it is in a Windows or any other platform, we can use that. That works as an infrastructure as a service because you are defining your infrastructure there and what is the platform which you want to do. But when it comes to the platform as a service, I'll take an example like Amazon Elastic Beanstalk, where it comes as a platform as a service because it is not giving, it is works as an abstract layer. Okay, you are just deploying your application as a jar or zip file. Everything is taken care by that. We never know how that application is running behind the scenes because we never know whether it's running in the Linux container or the whichever container. But there are some Elastic Beans extensions which is going to configure it, and that will be taken care by the platform. Like software as a service. Software as a service also, everything will be taken care by, because when we use the Office 365, we are not using anything. We just use the authentication policy. That's it. Rest of the things, because all the Office 365 application is running on the Azure clouds or somewhere, and it has the process of the multi-tenant where multiple organizations can access that application, but it's an isolated manner because there is a proper authentication and authorization mechanism which is in place for the software. Okay. And then we do have recently we are become like I said, right, we have again as a part of the application modernization, we are working on the serverless computing because, right, any organization which we are thinking about, they think about the cost, because if you are not using certain resources efficiently, how best we can do that. So that's where comes that function as a service. So it become a fourth way of a computing service where all these services and containers, it's like a trigger it and forget it. So most of the whatever the serverless which we are working, like Lambda functions or Azure functions, which is building, which we are right now. So it has a lot of flexibility, and so the cost associated to that, which is only when it is running this much stipulated time. So for that, they will be costing for that. Actually, that's where the function as a service becomes an important trend in terms of microservices building. Actually, okay. So there are serverless with respect to the serverless computing. There are a couple of there are a couple of function as a service feature which is providing by each of the cloud providers. Like if you take Amazon, it is providing the Amazon Lambda, AWS Lambda, and Azure function, Google function, and IBM Cloud Functions, which is helping a lot of in a larger extent with respect to that. Okay. So we discussed about the containerization, and we are building with respect to the how it help in the moving containerization to the cloud. But artificial intelligence had taken a large, I mean, a mammoth wave in term, and also storm in recent days actually. Okay, because it a technology which is always, it's go with a bias actually. Okay, artificial intelligence is always what we are thinking about is we should not think. It is making our human intelligence. We are shifting our human intelligence to the artificial intelligence actually. Okay, so what I'm thinking going forward is like since we are giving our all our human intelligence to the artificial, I mean machine intelligence actually. Okay, our we won't think much actually. I mean when people invented the calculator, we forgot to think and add or subtract through the brain actually. So like that, artificial intelligence also makes really people. I don't say lazy, but we won't think it in such a way that, but because the latest whatever the digital evolutions which has happened, uh, I think we are shifting our human intelligence to the artificial intelligence so that machines will take care of whatever the need and whether what is to decide. But whatever the training which we are giving it to the artificial intelligence and whatever the machines which is happening and what is happening in the deep learning in terms of how you are mimicking your human brain, that's there should be some kind of a limitations actually, because I don't think so like how human having an empathy in terms of when should we stop or something, but machine doesn't have it. Okay, I recently I read an article in terms of understood about there is one guy who is recently going for some kind of in a conference where he thinks about what he use the chat gpt, because chat gpt is becoming a lot of wave in terms of using the content generation actually. Okay, how that content generations will happen, because the content generations whatever the happening, we are giving that large language models, we call it as hallucinations of a bot and land. It gives you whether that information is accurate or not. We should think about it actually. Okay, so that conference guy, when he searched something in the generative chat gpt api, so he thinks about butter. Okay, so what is the history of butter, how it has been evolved and all those things. But in ancient days, or whatever the information which was given by the generative AI or chat GPT, it is like in ancient days, butter was using this as a currency. But in actual fact and books, in ancient days, they never used butter as a currency, but a milk or something which is accepted as a currency. Well, so the how we train that models, that is the how the information we will be able to fetch it actually. Okay, so there are certain certainly artificial intelligence will really help you in larger extent, in certain extent, but at the same time we should have an authenticity to the document, the content which is generating through the large language models actually. Okay, that's where human brain so what we are achieving from is like human brain, we need to match it to the artificial intelligence. It will take some time, but that authenticity and decision making is it always important to the whatever the content which we are giving it actually. Okay, okay, with respect to the AI microservices, where exactly it will helps actually, because we are using the automatic monitoring incident results. Okay, recently we built one application where we are we have an application where that our applications are running it in the cloud actually. Okay, we are every time the cloud alarms we will be setting it, there will be some threshold, and also how the Kafka dead letter queues, some if information is not passing to the actual topic and going to the dead letter topic, we never know, because we are not monitoring that kind of a features actually. So how we are going to automate that actually? So with that, using the AWS chatbot, we are trying to generate the notifications by generating the we have used certain services like DynamoDB, Lambda function, and even Bridge, so that what on SNS topic, so that we can get the information and generate the incident automatically by connecting to the service now, and then give the notifications to the alerting system, the development team, so that it will be easier for development team to fix the application in a very fast manner actually. And also optimize the resource outage actually. So whenever we build an application, the resource utilization is very much important because that's where the scalability is coming into picture. Because at the end of the day, everything is associated to the cost, because if you are not using the resource and you are utilizing it, it will cost incurred actually. So that's very important. And also it will help you in the troubleshooting. Okay. And also it will give you the how much we have to upfront capacity we have to give to the service and also to the automatic deployment.
Sorry, Mahendra, we are not seeing your screen. Yeah, we lost the screen. And can you share the screen?
We are able to see that.
We're able to see you.
I am able to see. Screen is visible to me.
For me,
It's visible.
visible.
Okay.
Okay. Can I go ahead?
Can I join
Yes.
1 second?
Yeah, please go ahead. You can do that.
Yeah. So what is the future of AI, which we are talking about actually? By 2030, AI might contribute because it becomes a critical technology component of a service enterprise strategy. Because any chatbot which we are seeing, right, whether it is helping to the content writing or generating, because recently I read one of the article in saying that when they clone that uh, one of the song, and then it becomes so popular and in the TikTok actually. So it was cloned through the AI application. So because see, that's where that whatever the adaptation of the technology is important actually, but authenticity and the adaptability is very much important. And also because AI is not it don't have an empathy like how humans having actually. Okay. So by 2030, AI might contribute up to 15 trillion to the global economy, according to the Code Brew Labs. And also there is a rapid development in terms of 14% higher in the 2000 by 2030. All potentially used replaced by AI and automation by 2030. This is just a number because we are not sure how the buzzword is going to take place, because the trend is happening, because everywhere whatever the content whatever we are seeing, ChatGPT, it is able to generate the content, whether it is able to generate an image, because there is a lot of content writing and content writing for this one, and customer service was taking place by the chatbot. Because uh, earlier we used to call a customer service and my service is not working, please book it. But since we are revolving and so much habituated to the application oriented architecture, everything becomes a chatbot. Because when if internet is not working, you go to the bot, my service, it will give you some options and it will give you the my internet is working, it automatically create the service desk incident so that the respective people will take it forward actually. At the same time, in the organizations as well, we do have some kind of chatbots where we can request to the service central. Suppose some certain services are not working, rather than going to the service central and creating a ticket, we can use that chatbot and create the incident actually. So that's where it will really help in terms of AI. So yeah, we have to use it in a very wisely actually. The last one which I want to talk about is service mesh. Service mesh is basically, we are working on microservices actually, but we are deploying it. It is running independently over the internet, and it is working on the network layer. But what about the security? So security is very much important in terms of, because that's where the service mesh, which will provide you a dedicated infrastructure layer, it lays on the in between the microservices actually. So whatever we give, it is like it works on the different architecture, which will provide that control pan on data plane. It actually, it gives the security, it gives the observability, because security in terms of like whatever the request which is going inside the service mesh and going to the another microservice, it will be encrypted. And access control, which will be giving it to the only the people who is having an access to that resource and this one. So the roles and privileges which will be provided. Since in microservices, this will be in the service mesh, the service to service communication will happen. So a proxy layer will be provided actually. And observability, because the whatever the traffic which is coming into the service mesh and going in between the one microservices to all these things will be traceable. Observability will take place actually. It gives how much consumption of where the services has started, where it is ended, where it is having a problem. It gives the complete trace of the telemetry in applications actually, so that if any problem occurs in the microservices, we can give that flexibility. Okay. Reliability is one of the important thing when you work in the microservice architecture, because there are certain patterns like circuit breaker, where it will certainly helps your applications to go back to the fallback method. Okay, because some certain services, suppose if you are working on PhonePe, you have some two accounts actually, back accounts. Okay, sometimes if service which is providing to the PhonePe, it might give us some problem and we ended up losing it, but yeah, it gives us that fallback option saying that yeah, this much period of time we are not using this one, there is some service disruptivity and maintainability. So circuit breaker, it gives you a pattern which really help you to give the certain kind, instead of giving some kind of a false or something, it will give you some kind of a fallback method where customer can completely rely on the whatever the transaction which he is making, or whatever the work which is whatever the amount of work which he is doing actually. Okay. On flexibility, yes, we have the flexibility because since we are working on the service mesh, there is a lot of flexibility in terms of communicating to the market, each of the microservices actually. Okay, yeah, platform independence. Yes, service mesh is works as a sidecar pattern, where if the cost-cutting concerns like observability and all these features, whatever we have defined, we can adapt it to any programming language actually. Okay. So this is just a architecture how the service mesh which is works actually, because see, service A, service B, service C, all these are microservices. This works in the data plane and the control plane where your applications was coming, like web apps, partner apps, and the software as a service applications. Control plane which does the your what you call like monitoring, load balancing, everything actually. Okay. With that, there is a last trend which it's not a trend actually, but yeah, because we are talking about all this containerization, cloud, artificial intelligence, and the services. But there are certain programmings, technologies, DevOps culture, and the tools which is really help us to do so, because there are a lot of characters which was involved in microservice architecture, which help you to make a better and sustainable architecture actually. Okay, so how we are going to deal with that? So with respect to the programming language, we can create your microservices through Java. Kotlin is really picking up because Kotlin is a consigns code compared to the Java. There is no, because it works on the JVM as well, but the only thing is the lighter weight and comparatively compared to Java code, Kotlin is really a less code actually. Yeah, Python, yeah, it is taking a predominantly as per the Stack Overflow tech survey. Kotlin and the Python and Java is going in head to head actually. Golang, it's really picking up because it's come from the Google. Node.js certainly has that feature because when you are working on any programming, when you're designing some programming in enterprise level, we need to think about it actually. So when I was working for a bank application, suppose if there is some banks which is in India, which they are not able to afford to give that infrastructure actually. Okay, suppose if I'm building some application which is in Java, even a simple COD operation, it takes some amount of memory, and then if they want to run it and scale it and maintain that application, it gives a lot of chaos actually. So for them it is a cubism. So what they go for, so we can suggest that suppose if you have some kind of a CRUD operations, we can build that Node.js, so which Node.js application where I know there is some security flaws, but we need to adhere to that. Yeah, Node.js certainly helps in microservice architecture in different ways actually. Okay, like I said in the programming, we do have a frameworks, libraries, and infrastructure as a service. Okay, Spring Boot is really making a lot of help in terms of building the microservice architecture, because Spring is evolving in a large extent. From Spring MVC and then to the Spring Boot, because from Spring Boot, Spring Framework and Spring MVC to Spring Boot, there are a lot of changes which was there actually. Okay, because in the under the Spring Boot umbrella, there are multiple projects which was there. Like we can work. Suppose if you want to build any standalone application in a short period of time, we can build it. Like Spring Cloud, Spring of anything which you want to do it, we can build that. Okay, Spring is certainly helps in a large extent because it works on the starter. Like if you want to build any Apache Kafka, we can build it. If you want to cloud gateway, we can give it. Yeah, so that way Spring is taking care. Spring Boot is really helping to create a microservice architecture. But what about there is a Kotlin framework which is really which will help you to build your Android applications or mobile and app applications actually. And Express.js, yes, certainly one of the framework which was used for building a microservice architecture like Flask, Django, and from the Python. I want to really talk about this infrastructure as a service, and infrastructure as a code. Because in the olden days, whatever the resource provisioning which is taking place is like which will be doing by the operation team. Okay, suppose if you want to create a MySQL database or any service which you want to do it, it is like a lot of manual work actually. But with respect to the infrastructure as a service, what we can do is everything we can do it in a simple JSON ML file where we can create your whatever the resources. Only thing is we need to understand the nomenclature of the CloudFormation, how it was built actually. Okay, so a Terraform is which will work for any cloud provider, but CloudFormation which is limitations in terms of using only to the AWS section. So with respect to the CloudFormation, you design your provisioning of the resource, like what is the Lambda function which you want to create it, what are the engines, what are the IAM rules which you want to create, like identity access management, and also what is the application which you want to do it. I mean, rest, if you just deploy it, automatically the applications with provisioning will happen actually. Okay, like again, that is with respect to the CloudFormation, and Terraform, which whatever the infrastructure is, like whatever the provisioning things which you are doing it, it will certainly help you develop in whatever this develop which will develop in the any kind of a CloudFormation actually. Okay, yeah, I certainly agree that I forgot to mention that in the .NET. Yeah, so sorry for that. Yeah, for .NET is also Microsoft product which I want, because since I am from the Java background, I might have included one Java. Apologies for that. Okay, and containerization, like I said, Docker, Swarm, Kubernetes, and Podman, because all these containerization and orchestration depends on the organization's enterprise strategy is going to come into place. Okay, some people was very much, if you want to do some kind of an orchestration, they are very much used to the Docker Swarm actually. Kubernetes, they will go for a large application section. Okay, service mesh, yes, there is service mesh which works on the three open source applications. One is Istio, Linked, and Council. Istio provides you the kind of an as a lot of security features in terms of this one building like I said, right, service outcome. It will be it is the dedicated infrastructure layer between the microservices to microservices actually. Okay, Linked, it enhances the certain features like load balancing, monitoring of the traffic, and all these things which is not providing by the Istio. And Council is another open source product which is giving that kind of flexibility. Okay, And CI/CD and yes, we are there are a plethora of options which we have, like Jenkins, GitHub. With respect to Jenkins, you can build your Jenkins pipeline with the multiple stages, where each stage like build, test, and deploy it, and then we can use that. And GitHub, using the GitHub Actions, which we can perform whatever the content which you I mean source code management, where you do it. It has this own kind of an CI/CD platform, and GitLab, Circle CI, and Bitbucket, which is having that. TeamCity, which is developed by the JetBrains, which is that certainly helps that feature actually. Okay, monitoring observability. Yes, in fact, whatever the microservices which we are creating it certainly helps to. We have to monitor applications actually. Okay, so there are some characters like Prometheus, Grafana, Logse, and Dynatrace certainly helps you in certainly helps you in whatever the how the information is tracing, or suppose if any problem is coming, what is the metric, what is the usage of the resources like CPU, monitoring, all this. Basically it is a health check, and how the tracing is happening from the one microservices to another microservice. All these things we can do it in the monitoring and observability. With that, along with that, since AI is picking up, like GitHub Pilot, which is helps as an AI pair programming. And recently, yesterday, I read Google's DeepMind CEO informed that they're going to create an Eclipse Chat GPT. I'm not sure how it is going to help, because this it might give the large language models to help developers to deliver their feature or the whatever the task which they have, but we are not thinking, because in olden days, in vintage people like us, we will be like me, we used to think what is the language, how we are going to do it, what is the feature which we are going to do it, what is the logic which we are in. But that with the introduction of the GitHub or Copilot or AI programming, all these things, it is making us to not to think anything, let the AI program or pay program, it does give the suggestions so that we can implement that and we can deliver that. Okay, so yes, like last one, like there are certain design patterns which will help you for the microservices actually, like based on the business capability, like in the e-commerce, order service is one business capability, payment is one server, shipping is one this one, checkout, on everything is like a business capability around which we built actually. Again, decomposed by domain. Again, when it comes to the when we create a payment service, it's like a business capability. Another subdomain is whether you are going to use UPI domain or any other cards domain or net credit card domain, or these things actually. So that one. Okay, Strangler pattern certainly helps you decomposing your applications, your monolithic applications. This one. Integration patterns like API gateway certainly helps, like how Service Mesh is there. Google's, I mean Spring Cloud Gateway, where it will certainly helps you to give you the flexibility to give the kind of a routing mechanism where whatever the applications, whatever the microservices which you want to connect it has to pass through that API gateway. So that will certainly helps actually. Yeah, aggregation pattern and client-side UI composition pattern. Like I said, right, we are working on the micro front-end frameworks actually. Okay, where micro front-end, where we will be since the Angular and React as in popular frameworks, where it works on the componentization, everything becomes a kind of a complete not a loosely coupled architecture, but client-side UI composition pattern, which certainly helps to do the any kind of feature which you want to build in the client side and server side actually. Okay, database patterns. Like I said, right, microservices, if you work on the greenfield project, we can create a separate database altogether, so that it will help. No need to rely on the shared database which was using in the monolithic applications, where monolithic applications, yeah, in fact we can use in the microservice architecture also. So 3 through 4 microservices which will be using in the, that is one of the design pattern which was available here. Common query responsibility segregation, because this CQRS is certainly helps in a large extent in terms of, suppose when you are working on, because when you do a database cluster, right, we should have a read and write features actually. So we should so the CQ command query responsibility segregation certainly helps. Certain requests should go only to the read cluster, and certain requests should go um, only to the write nodes actually. So that is how it will give you the performance, and there will be less load in terms of, because when it comes to the database transactions, right, we are often like even e-commerce depends on it actually. If you're working on an e-commerce application, there will be a lot of write transactions which will be taking place. So their command query responsibility segregation certainly helps to divide your transactions or logging and a request to the particular master node or cluster nodes actually. Saga pattern again, yeah, it will this is one of the design pattern which will do the designing your microservice architecture. Observability platform, like I said in the previous slide, there are certain mechanisms, because right, in microservices only the application and business capability is taking place. Rest of the things which will work as a sidecar patterns, where logging mechanism no need to think about it, because service mesh will take care of it. Performance and metrics certainly helps, and distributed tracing also taking, because all these things we no need to implement it actually, okay, in the application logging. So we can give that handover that work to the certain tools which is really helping us, okay. And then a cost cutting concerns patterns, yes, when you work on the Spring Boot microservices, Spring Boot applications, where we can externalize your properties, where suppose if you want to do property wise or these things, suppose there is some kind of an business capability, business features will be there, okay. So those things we need to have it tightly coupled with an application. We can externalize that and put it into the GitHub or Bitbucket and any source code repository, so that if you want to change some value which should reflect in the front end or something, it will immediately, we can just update it and roll out, so that it will pick up the next this one. So that's where this externalizing the configuration certainly helps. Okay, service discovery, yes, in fact when you work on since we are talking about a Spring Boot, Spring Boot certainly has this in the service discovery pattern which help you, like Eureka, where we can log your applications to that Eureka, so that it will see the whether it is available or not. Okay, circuit breaker pattern, yes, certainly helps, because circuit breaker pattern is one of the important design pattern for the microservices to give you the resiliency and fault tolerance for the microservices with application actually. Blue-green deployment pattern, yes, after developing everything to the composing and working on design patterns, blue-green deployment certainly helps actually. What is blue-green deployment? Blue-green is nothing. Blue is nothing but whatever the application which you have already. We are just adding some feature and moving it. But green deployment is altogether a new one. There is another pattern also there, canary deployment, where we'll do that kind of an A/B testing, or certain people should be able to get that certain feature, something like that. Okay, so yes. So I just this is the last slide which I want to talk about. It's about the real world use cases. It is, everyone knows of, I mean, most of the audience is aware about how the Netflix is giving a lot of streaming platforms. So in fact, whatever the Netflix infrastructure, everything runs on the AWS cloud. Okay, and Spotify, how they done the, if you listen Spotify app and listen the music, the music is so good, and it will give a lot of productivity, and in terms of you feel really a good and enhancing feature actually. I mean, enhancing, what you call, you will feel so much of happiness when you listen from the Spotify music actually, because it has that flexibility in terms of the, whatever the development which has done. I think microservices is certainly helps to, in a greater extent, give the customer experience and the customer usage. Okay. At the last, I would like to state one thing. Architecture is not an equation. It is a continuous evolution. it and going with a snapshot. Thank you, and thanks for listening my session today. I've handed over to Sunil. Thank you.
Mm,
If you have
yeah,
any questions, yeah, I'm happy to take questions actually.
yeah. Wait, how can we download this video to again review this scenario?
Teacher Prasad, we'll upload this entire meeting in the YouTube channel. Okay, we already posted the YouTube.
Hello, this is Chandra. Am I audible?
Yeah, yes, sir. You're audible. Please go ahead.
Yeah, I put the channel, CSA channel in the chat. This video will be uploaded into that, by tomorrow. And you can have a look at it again, whenever you want.
Okay, thank you. When the functional side, function as a service is presented, then how can the request will come in that scenario? Whenever there is a scenario is there in the microservices, there must be there must be a container just like that, where it will accept the request or response processing. In case of function as a service, how the request will come to the function, and how it will be processed and service to the end user. That is a one small question. Might be it is a
Problem.
not
I can just help you that. Let us say we have some order event, okay, in e-commerce application or something. Okay. We have an order event. It has some structure. Okay. When you create an order, when you go to the payment section, right? What it does and then from you done the payment and then going to the checkout and then you done something. Okay. So everything is an event basically. Okay. Whatever the event which is triggered, that Lambda function it will handle the events basically. Okay. When it is taking the order, it is taking the order information and everything is an event basically. Okay. So whatever the Lambda function as a service which you are doing it will take it, handle that event, write some it will perform some kind of a business logic. It will generate the order ID or something and then give it back to the next event actually. So in that handle request, basically I'm talking inside the technical Lambda function, inside the handle request, how it is happening. So it will take the event information from the source. It can be any other systems like previous product or a previous page or something, and it will handle something. It will do some kind of a calculation and it will provide you that next operation section. So it does only a stipulated time of what it want to do it actually. Suppose if you want to run that application or run something, suppose if you want to get that application, okay, I'll put it in a different way. Suppose if you are going to access some Spotify list actually. Okay, so what is happening is you are searching something. Okay, you are given some content, like it's a prompt in the whatever that. Suppose if I'm searching for the avatar wave or something song or something, it is an event. It will take as an input. That is an event basically. Okay, and it will give you and it will provide you the list actually. So the Lambda function, what are the function of the service which is doing, take the input, call to that service and give the result. That's it. It is fire and forget. That is what it is going to happen in the function as a service. I hope it is.
yes, it appears to be a event driven programming, just like that, right? When
yes, most of the e-commerce application, like whatever we do in the Amazon, right, it is happening through the event driven architecture only.
Okay, yeah, thank you. Yeah, clarified.
Hello, am I audible?
Yes.
Yes.
Yep.
So when it comes to microservice, always Netflix becomes the poster boy, right? We give that as an example. But also recently, right, I would like to know your thoughts on the recent case of where Amazon Prime, their services, they have moved from microservices into a monolith, and posted a blog on how it has helped them to reduce their cost by over 90%. What are your thoughts on it? Is there going to be a reverse trend on it?
I mean, depends on, that's what I'm saying. See, when they design their application, right, they should choose the design pattern such a way that whether we have to really go to the microservice architecture. Okay. So if the application is able to give you a lot of flexibility, okay, in terms of, so even if it's a small feature, if you're introducing, and then if you are able to deliver it to the customers in a real time, then I'm not saying that we don't have to go back to the microservice architecture. We can just stick to the microservice monolithic only. So earlier, maybe they didn't think about why, if it is a small application and then if you're migrating to the microservices, doesn't make sense actually. Let's stick to the monolithic and implement whatever the feature and deploy to the customer.
But Prime is definitely not a small application, right? Amazon Prime is not going to be that small.
Yes. Yeah.
So, but I could not comprehend the reasoning. Why such a big application deployed as a microservices? Why would they move back to monolith?
I mean,
So,
depends on the use case, sir, actually. Depends on the use case, on how the organizations, why, I mean, because there are a lot of factors is coming into place, because microservices, there are plethora of components is coming into place actually, because like I said, one example, like as when I was working for Vijaya Bank, right, one of the bank which is there in my previous company, where they are not about, afford to put their Spring Boot application to their infrastructure, because their cost is very less actually, because my application is a simple microservice. So what we went back to is in the review boarding and architecture decision, let's build a simple Node.js application where it does the CRUD application, so that it will give the need to them actually, because there are a lot of factors actually why they went back to. But I'm not even I heard about that topic, but I didn't completely go about why they went to go back to the old tradition of using the monolithic actually. But there are various factors coming into place, like when they're choosing to the microservice, they might have not gone through that kind of in a bounded context, components properly, and the design patterns, whether the business capabilities are mixing each other. So maybe, yeah, there are a lot of factors coming into place.
okay, thank you.
Yeah, thank you.
Yeah, Mahindra, I'm Girija Prasad. Actually, how actually Java can have the multi-threading environment where it can accept multiple requests and process all the requests.
Yeah.
What are the advantages that microservices provides with regard to the
Yes. I think
with regard to
multi-threading multi-threading, it becomes a, yes, it's a very important topic actually, because we are working on a asynchronous events actually. Okay. I think some extent Spring Web Flux has done some kind of an asynchronizing and completable feature, which is there in the Java 8 introduced, which will certainly helps in the multi-threading programming actually. But what I understood in Java 21 is from Java 17 and 21 is they're introducing the virtual threads, which will certainly help in the project Loom. I think there we can certainly helps how the concurrency can be achieved. This one actually, yeah. Yes,
thank you.
Yeah, Mr. Sudhakar has put a question in the chat. He's asking, is microservices used in enterprise level security?
Yes, microservices certainly adhere to the security level. That's what I've mentioned, right? When it comes to the service mesh, it works as a dedicated infrastructure layer for the security actually. So when you have the service to service communication, it has to pass through the whatever the traffic through the service control pan of service mesh, where we will be doing the whatever the request which is coming through, which will be doing it in encryption actually. So yeah, and also we will be providing the access controls so that the right people and the right privileges and roles which who is having, so those people can able to access that microservices APIs.
Okay. Sudhakar, you have raised your hand. Okay.
I hope I answered
Yes.
Sudhakar's question.
But then, any other questions, please? It's okay. Sunil,
Yeah.
what?
Yes, sir. So thank you, thank you, Mahendra, for taking your valuable time and joining this wonderful webinar. Thank you, everyone, at the same, and apologies for making trouble in between the session and again rejoin back. Thank you, everyone.
Thank you everyone. Thanks for listening
Yeah.
to the session.
We should mind that today's program is very informative. Thank you very much.
Thank you.
the
I can contribute anytime.
Microservices, the advantages of microservices, like decomponenting, componentization, decoupling, componentization, continuous delivery, agility.
Yes.
The one point, you mentioned, which is a little alarming. You said 38% of our jobs will be replaced by AI and automation by 2030. We all should start working more creatively to keep our seats.
Yes,
Thank you.
sir. Yes, sir. Because that reminds me today's in one of the article, because when one world chess champion, Gary Kasparov, introduced how the brute force algorithm is making chess game in a masterful way. Because AI is, yeah, certainly helps. At the same time, we should be very. I'm a bookish guy, so I rely on books and generals.
Yeah, I think we should no longer call it artificial intelligence. We should call it super intelligence.
Yeah. Yeah.
Okay.
Okay.
Yeah.
Okay.
Thank you very much, Mahinder. It was very informative and good session. Thanks, Harsha, Sunil.
Thanks, everyone. Thanks, sir.
to
Thanks for
Kirti.
your. Yeah.
Yeah.